So again, if you have to refer to your notes from yesterday from the reading to help you with the bell ringer. Bless you. Bless you. All right, okay, so we talked about geocentric model already. Don't need to talk about that too much anymore. Right? That was the idea. Focus quite a bit about how the Earth is stationary, center in the universe. Okay, we'll talk about Galileo today, a few quotes where he directly challenges the scripture in the Bible, which is opening up the ideas of these new forms of thinking, especially when it comes to the heliocentric model. So, who came up with the heliocentric model? What's his name again? What was his name? Connor? Copernicus. Copernicus, yes. Good job. Football. Great. Okay. All right, so Copernicus. Good, good. So with Copernicus, he thought that the sun is actually the center of the solar system here, and the planets revolve around the sun. Okay, good, good. So Copernicus, one thing to note about him is that he thought that these orbits, these revolutions around the sun were perfect circles. Okay, he thought they were perfect circles. And that's where Kepler critiques him a bit. But with Kepler, let's just talk about him first. How does he prove Copernicus's heliocentric theory? What does he say? Well, how does he just kind of prove it more? Go ahead, Chris.
He established the three laws.
All right, yeah, good, good, good. So with Kepler, he's realizing that, yeah, you know what, with observation and looking out into the cosmos here, we can realize that these planets do revolve around the sun. And it's not a perfect circle, right? That's where he contradicts Copernicus. He does say that it's more of an ellipse shape, right? It's more of an oval egg shape, okay? And depending on, which we'll talk more about with Newton, okay, where Newton bounds us even more, depending on the mass and the relative distance this planet has from the sun, that's going to depend on its orbit, right? So we'll talk about the mass and the distance from the sun here today with Newton to depict how these orbits look. All right, and then Galileo. Galileo, as he further proved the heliocentric theory. What do we know about? How does it go ahead?
He made a telescope.
Okay, so with the telescope, made some more observations. Good about what?
Planets around the sun.
Yeah, good job, good job. So he's kind of disproving that these heavenly bodies, these planets, they're not, right? They're more made of elements that you can find here on Earth. And that these planets act in a way and revolve around the sun, much like the Earth does, proving the heliocentric theory. He also made observations of other places, like what? What other observations did he make specifically? So he looked at the moon, right? What do you say about the moon? Ozzy.
And then like those in craters.
Yeah, good job, good job. So he's proven that there's a surface of the moon. It's not, again, just a beacon of light or anything like that. All right, good. And then he also looked at what? What else did he look at? Which I thought would be kind of blinding, staring right at the sun. Go ahead, Paul.
What he did with it.
Well, yeah, he was looking at black spots. You know, he was looking at the sunspots of the sun. He's realizing that it's just not this beacon of light again, that there are some imperfections to it. Okay. And then also, what did he see? What else did he look at? The moons of Paul. Yeah, good job, good job. So it's all the moons of Jupiter. He realized, you know what? The moon, like ours here around Earth, must revolve around the Earth, again, proving this sense of gravity. And that is revolving around the Earth. Okay. So with Galileo, he proves that these planets and moons revolve around an object of greater mass. Okay, depending on the distance, they revolve around this object, like we see with the Earth, the Sun, the Moon, and the Earth. Right. Also, he focused on these moons of Jupiter, Sol Titan, Thanos is from, right? Yeah. Okay. Just throwing that one out there. So I'll let you guys know. All right. Good. So anyway, there you go with Galileo and Kepler. All right. One thing to note about Kepler too. The book didn't mention this much, but he also depicted more about with the tides. Okay, so if it's a low or high tide, depending on where the moon's located, it will bring the tide into a lower or a higher tide. So whenever you go to the beach, you hear that off. And again, that's just more with the gravity pull of the moon, okay, on the surface of the Earth. And depending where the moon's located, let's say right in front of the sun, almost like an ellipse, then there's going to be even higher tides. So that's something to note that Kepler brought to the attention of people. So there you go. Galileo, Kepler, they're proving this heliocentric model through mathematics. They're proving it through observations and challenging the teachings of the church. All right, is there any questions on that, guys? Any questions? Okay, we're going to talk about Newton here today and focus more on medicine and chemistry. Okay, and we'll even mention a little bit about we'll see. We might get to the scientific method. It just depends how fast we move. If not, we'll just focus that on tomorrow, and I'll put your study guide out for tomorrow. Okay, that's the goal. All right, that's the goal. Here's your terms for today. And I didn't grade your bell ringers from last week, right? No? All right, I'll make sure I grade them this week. Well, we'll see how far we get. We'll see where we get here. There you go. We got Newton. Okay, Newton's work here. Andreas Vesalius, William Harvey, and Robert Boyle. Okay, so we'll talk a little bit more about these key figures of the scientific revolution. You guys need another minute here? Okay, no problem. All right, so Isaac Newton, I'm sure you heard of that guy before. So what do you know about Isaac Newton here? What do you have? What do we got? Isaac Newton. Talk about his laws of gravity here today. Paul, what do you have?
He had a degree of laws, which goes for that a body remains in a state of rest, compelled to change by force that they put on it. And then the second one is that the change of motion, the change of velocity times the mass of the body is proportional to the force impressed. And three is for every action in nature, there is an equal and opposite.
All right, hey, good job, good job. So Isaac Newton, named for his laws of gravity, okay, and the world machine structure, the world machine model, and depicting how these planets move. Okay, for the geocentric theory, the model, they believe that this outer rim outside of what we could not see and observe, okay, this was moved by God. Okay, these planets, they all move by God. Okay, and obviously the sun around the earth, what they say of the geocentric model. But Newton thinking of in a different way. He's saying, well, we need to try to prove this theory of motion. Right? And the only way we can do that is just trying to realize with these planets, there's a force of gravity that's pulling, okay, depending on its mass and depending on how close they might be to a certain object, this is going to bring in these planets to, let's say, revolve around the sun. So he wants to try to come up with an idea, the structure, this idea of where these planets would move, depending on its mass and depending on its distance from a, let's say, larger body. In this case, with the heliocentric model, we know the sun's at the center, and these planets, depending on its mass and distance from the sun, that's going to depend on its movement, its orbit around the Earth, or sorry, the sun. In that case. All right, so what do we have here for Newton's Principia? Newton's Principia, that's just pretty much what Paul just relayed to us with laws of motion. That's his famed work, right? So make sure you guys remember that. Okay, that's where he depicted his laws of motion and this kind of this world mechanism, this world structure model of movement. Okay, and you guys, I'm sure, heard an object in motion stays in motion, right? Yeah, my grandpa the other day came over to help me frame out some walls. And he said that. He's about 75 years old, but he can get around pretty good. A body in motion stays in motion. That's what he says. I'm like, oh, yeah, that's a good way to look at it, right? Paul?
He's the same dude who got that apple.
Yeah, the apple fell on his head. Yep, the old tale where the apple fell on his head and he's realizing, what pushed that apple to fall on my head?
Yeah, they discovered
How did it fall?
people were floating around.
Yeah, there you go, there you go. So yeah, the apple fell on his head and he's realizing, you know what, I want to try to make it idea a reason of why this apple just fell down off my head. And that's where he comes up with these laws of gravity. All right, so Andreas, Vesalius, what we got here? I'm gonna pronounce that right. Vesalius. Good job. Good job. Amelia, thank you. Good, Gary, I'm sorry. Yeah, good job. So he's the father of anatomy, right? The father of the human body, anatomy of the body, right? And before this, there is a scientist named Galen of ancient Greece and Rome that he dissected animals to try to detect the organs of the body. And it was thought that the liver actually pumped blood throughout the body. Is that right? Is that right? Oh, no. Okay. So Vesalius comes around and says, nope, we're actually going to analyze real bodies here. He's going to analyze real bodies. So he dissected the human body and went through and looked at the anatomy of the body and really depicted muscle formations, organs, okay, and realizing that this is the proper anatomy, the proper understanding of the anatomy of the body. Okay, so how did he do it? Well, he actually dissected human bodies. What's up?
Did you do this dissection?
Yes, he did. He did. And when we get to William Harvey, he does it in weirder ways. He actually hangs the body upside down to see exactly how the blood flows through these arteries, veins, arteries. And he realizes that there is obviously to use emotion when it comes to blood flow. So veins and arteries. Dr. Carolyn, go ahead.
I believe it was also a punishment to get your body dissected.
Yeah, how about it? So William Harvey, he depicts really just with the motion of blood through the body. And he does so by, again, dissecting bodies, actually human bodies. And this was unheard of the time. Even today, it might be a little bit, oh, geez. I guess every now and then you see these shows where they're kind of looking at the body and seeing how these people die in these crazy ways. Maybe it's a way of trying to understand it even more when it comes to obviously depicting the anatomy of the body. Thinking about the body just being cut open on it.
Oh, stop.
All right, so sorry. I know I don't want to think about it either. Okay, Robert Boyle, last one here. We'll move on. What do we got? Go ahead, Connor. All right, good job. Good job. Okay, so we'll talk about the scientific method here soon enough. Okay, and we'll mention more about obviously the step-by-step process of observation. Then you formulate a hypothesis and you perform an experiment. And then you look at the results from that experiment and realize, you know what, maybe I got to formulate my hypothesis a little bit better. Maybe we got to reshape it. Or we like our results that prove our hypothesis and we publish it. All right, so moving on here. Go back to Galileo. I'm not going to have you read today. Yeah, I just want to make sure I get through this material here first. So Galileo, okay, we talked about him already. I think I already showed you this slide, right? I know I skipped through it pretty quick, but we talked about him as observations of, right, Jupiter, its 4 moons, the sun, its dark spots, and the Earth's moon, its uneven surface. So again, utilizing observation, they can depict and understand the world around them and try to prove more of this, let's say, heliocentric model of the time. All right, one thing with Galileo, did he find himself into some trouble? We read about this yesterday. Did he find himself into some trouble? Paul?
Yeah, he got tried for his beliefs, and basically he decided, he apologized and said that he didn't say he didn't believe in his ideas, but he didn't speak out about them.
Yeah, good job. So yeah, he was questioned by the Catholic Church. Okay, he was in a way trialed for his crimes of being a heretic, of challenging the geocentric model. And as he's leaving, he's like, oh yeah, these guys are dumb, right? They need to go through observation here. They need to prove their findings. Well, anyway, here's some more quotes here I thought would really prove for Galileo's insight. So let's read through them here. So Chronicles 16:30, fear before him all the earth, the world also shall be stable, that it be not moved. Meaning the geocentric theory, right? Saying that the earth's at the center and it's not moved. So Galileo literally depicted this out of the Bible and said, well, maybe we can look at some more reasoning here with the heliocentric model. All right, he set the earth on its foundation. It can never be moved. So again, he's picking out these phrases from the Bible and expressing that, you know what, maybe we need to elaborate more. Say among the heathen that the Lord reigneth, the world also shall be established, that it shall not be moved. He shall judge the people righteously. So again, geocentric model, right? And then the sun also riseth, the sun goeth down, and haseth to the place where he arose. So Galileo, with his questioning, with his interpretations of the Bible, and with this ancient Rome Inquisition that he was threatened with, he wanted to try to prove his point. And the way he's doing that is literally picking out these phrases from the Bible and saying, maybe we can elaborate more. Okay, he's not saying that we should just get rid of our faith. He's not saying that at all. He's just saying that it's open to interpretation where we can learn and understand the world a little bit more through scientific reasoning. All right, so faith first science. Again, here's more of a quote of Galileo. He argues the church should reinterpret the scripture truths if they conflict with scientific truths. So again, that these people shouldn't be trialed and killed in obviously these harsh forms by the Catholic Church just if they oppose the world around them. If they come up with these new ideas that might question the church's viewpoints. Again, he's not telling anybody to just be, let's say, an atheist or just forget about religion. He's saying that we need to focus more on moving in a different direction of observation, of proving the world around us. Okay, so I just want to make that clear distinction there. All right, so Isaac Newton's views of the universe. So again, with rebuilding the universe, Newton came up with these laws of gravity. Okay, he's realizing that there needs to be some way to explain these planetary motions, right? He needs to explain how the planets revolve around the Earth. And the way he does so is through his Principia, right? We just went over that with the term. Okay, his laws of gravity. Again, yeah, rumor has it that this apple fell on his head, and he's trying to figure out exactly how this apple fell on his head. What brought it down? Why did it just shoot straight up in the air if this apple were to just, let's say, separate from the tree? Or shoot to the side? Why did it fall down? Well, the reason for it is gravity. And he explains these planets' motion through gravity, further proving Kepler and Copernicus's view of the heliocentric model, challenging the geocentric model, right? And focusing more on a direction of reasoning, of insight. So again, the universal law of gravitation and his Principia, which is expressed pretty heavily, and his 3 laws of gravity, which we kind of know already, right? This object in motion stays in motion depending on an object's acceleration with its mass. Okay, you'll have to times that, obviously, mass based off of that, right? And focusing more on this planetary motion. All right, so I'm going to go through this here. I posted this PowerPoint for you guys. You can follow along and as we go through it, or go back and reference it if need be. All right, so with this universal law of gravity, again, he wants to try to prove that these planets, why they don't just go in a straight line. Why isn't the, let's say, planets, the sun, the solar system, the whole universe just moving in a straight line? Well, it needs to be explained by a sense of gravity. Okay, he calls the world machine concept. Again, it's not just God outside of, let's say, the observational views of the universe pushing these planets. Okay, it's more dependent on this world machine concept and how the sun, obviously, is a larger body. Okay, the Earth rotating around the sun, revolving around the sun, okay, with its mass and depending on its relative distance from the sun, is pulled in by a force of gravity. And this allows for the Earth and the other planets to revolve around the sun depending on its mass and depending on its distance from the sun. Again, it's not a perfect circle, right? These orbits. It's more of an elliptical. It's more of a, let's say, egg shape, okay, oval, rather than its perfect circle, as Copernicus said. So again, it just depends on the mass of the object and its distance from, let's say, the larger object that's pulling
the planets in this orbit, in this revolution around the sun. All right, and again, they call that the world machine concept, right? So that's where Newton was proving that it's just not God on the outer edge, the outer rim of the universe pushing these planets in motion. Okay, he needed to prove it through scientific reasoning. And this is where his laws of gravity come into play. So I think that's a good diagram of really stating how this world machine structure, this world machine model works. So this gravitational pull of the sun and the planet is revolving around the sun based off its distance and its mass. All right, so other breakthroughs here. So like I was talking about with the anatomy of the body. So Galen, ancient Rome and Greece, he depicted a lot of the organs, and he came up with these ideas of muscle structure and what were the processes, the jobs of these organs by dissecting animals. Again, it's kind of inhumane. It seemed a little strange if someone would just cut open an actual human body and analyze it. So with Galen, he thought that the liver actually was this source of pumping the blood through the body. Okay, we all know that's wrong. But at the time, again, that was with what we understood from ancient Rome and Greece, okay, with dissecting animals. Later wouldn't happen until what we talk about with Andreas Vesalius. So he comes around and actually dissects the human body and proves that, well, these organs, these muscles are a little bit different than what we find in an animal. Okay, and proves more with obviously the workings of the dissecting of the body. They can understand the organs and the muscles a little bit better. All right, so with Andreas Vesalius, again, on the fabric of the human body, he published an accurate, really diagram, the anatomy of the body and understanding the muscles and the organs and how they work and coincide with one another and cooperate with one another by actually dissecting human bodies. It's gross, it's disgusting to think about, but his depictions were very accurate. Again, what better way to do it than actually dissecting the human body? So with that, he really came up with an accurate view of what the muscle structures of the body looks like, of what the organs look like, and really just kind of depicting how they work within the body. Again, the brain, not so much, right? Even still this day, we're questioning what the brain can actually do. And with all the forms of technology that we have, it's still up in interpretation. So in many cases, he kind of stayed away from that. There was an idea too where the brain and the body act separate from one another. Okay, this was an idea of dualism. So I wanted to make sure you guys noted that. I didn't put in your vocab, but with dualism, and if you take psychology, they talk about that quite a bit, where the brain and the body act in separate and different from one another. But Rene Descartes, which if you guys check out your textbook, they actually talk about him in this section here of the scientific revolution. He mentions quite a bit about how that is just not accurate, right? We need to base off our observations that's interpreted in the brain and it reacts with the body. Okay, it's not two separate entities. They work together. All right, main thing to know about Vesalius here is that he's the founder of modern human anatomy because he literally cut open bodies. What a crazy man. All right, so another breakthrough here, William Harvey on the motion of the heart and blood. So he tried to figure out exactly how the blood flows through the body, okay? And he does so by actually cutting open the body and trying to actually pump blood through the veins of a human body. And you realize that these veins are carriers of blood, okay? So you have arteries, then you have veins. He even interpreted that. So you guys know arteries and veins, what's the difference? Anybody? You guys know this with health class? Matt?
Arteries bring blood away from the heart. Veins bring blood back to it.
Awesome, good job. So depending on the oxygen level, obviously with veins, they're bringing it back to the heart. It's a lower oxygen arteries away from the heart, higher oxygen to the rest of the body. All right, good. And that's all found with William Harvey. So make sure you note that his main contributions to science is interpreting the body, blood flow, the anatomy of the body, and more in particular with veins and arteries. All right, is there any questions here on these guys? No? All right, again, so this is really new to the times, right? With this scientific method, we'll talk about this here more tomorrow with Sir Francis Bacon and how he describes that we need to observe, we need to go through a step-by-step process of experimentation to come up with their own interpretations around it. So we just can't go strictly based off of what the Bible, what the church has to say. All right. Okay, that's all I have for today. We'll finish up notes tomorrow, and I'll have your study guide out, which you'll have time to work on that. If you have any questions, please feel free to ask me about any of the questions on the study guide. All right. Hopefully, Mrs. O'Neill can get a booklet for you. That'd be great, or a Quizlet. And you guys can practice on that, and that will help you. All right, cool.